Hi guys, and welcome to my channel. In this video my topic is area and volume. This is usually covered in Form 3, Form 4 and Form 5 and it's done in math. But the shapes that I plan to include today are different. These are cones, pyramids, spheres, etc. So they're the more complicated area volume questions that I'm looking at in this video, and I plan to do a few complex questions as well. So please stay tuned to see what I have in store. Now, before we get into the questions, we need to cover the formulae. So these are the few of the formulae that you need to be familiar with. If I had a cylinder, the volume of this would be pi r squared by h. Now, where do I get pi r squared? From here. That's the area of the circle here multiplied by the height. So that's a cylinder. A sphere now, it's 4 over 3 pi r cubed. That's the volume for that one. A cone is 1/3 pi r squared by h. Again, as the circle at the bottom of the here, I'm finding the area of this, finding 1/3 of this and multiplying by h, where h is the height. A square-based pyramid, I will find the volume by taking 1/3 b by b, that is actually like the sides of the square, so it's like side squared by h. If now I will given a rectangular prism, well then it's just simply these three measurements I'll multiply. The area of the base multiplied by the height, so that's LW by h. The triangular base prism would go like this: height by base on 2, that's the area of this triangle here, multiplied by the height. So these are the shapes that I plan to include. However, there are a few that are not in this table, and those are regular tetrahedron, which is a regular pyramid, and a rectangular base pyramid. Now, in a tetrahedron and a rectangular base pyramid, they look like this. I have a tetrahedron and the volume is this. It's 1/3 A by H. Now what is A? A is actually the area of the whole base here. So that is the area of this base triangle here, right? Now this small a is just one of the measurements of the side, but I don't have the other measurement here, right? But however it is you need to find the area of this base triangle, you do so. You could use Heron's formula, height by base on 2, or half AB sine C. I have another video on how to find the area of triangles in case you need to look at that. Once you find the area of A, then you multiply by height, which is the vertical distance here, and you multiply by 1/3. Now that is for a tetrahedron. For a rectangular base pyramid, now this is how the shape would look like. This is what we do. We have to find the volume by taking 1/3 again by LW by h. Now what is L and W? L and W are simply the length and the width of the base rectangle multiplied by h, which is the vertical height. Right? So please, I hope you all understand these formulae that I have listed out here. Now I want to get into some questions. This is example 1. We were asked to find the volume of this shape, right? So first thing we need to figure out, what shape is this? This is a square-based pyramid. So according to this, the volume is 1/3 L squared by h. What is L? L is this distance here and this distance here. Because it's a square, that distance is the same. So it's simply 1/3 by 10 by 10 by 12. And that will be 400 centimeters cubed. Example 2 now. Now we are asked again to find the volume of this shape. In this shape, this is actually a triangle at the base, right? So this is a tetrahedron. So I need to find the area of this shape here, because the volume is actually 1/3 the area of the base triangle multiplied by height. Now this base triangle has measurements. Now it's a right angle here, so it's actually 4 by 6 on 2. So this would be 4 by 6 on 2 multiplied by the vertical height, which is 7. So notice we are not using the distance 5 on 5 here, right? So this section here is actually here. This is height, and well, of course, this is the vertical, right? And this works out to be 8 meters cubed. Now make sure that you put the cube on whatever measurement it is you're working with, otherwise you can lose marks for this. Now let's move on to our other example. Third example asks for the volume of this cone. Now again, what is the volume of a cone? 1/3 pi r squared h. Again, 1/3, my pi is 22 over 7. My r is this radius here, which is 8. 8 by 8 multiplied by 15, which is my height. Now, once I plug in all these values and I work it out, I will get my answer to be 714,286 millimeters cubed. So this is my solution for my third example. Now let's move on to the fourth example. Example 4 now. So now I have a closed container and it's made up of a cylinder followed and which has a hemisphere here on the section, right? There's a radius here which is 9 and the distance here which is 18. So we're asked to calculate the surface area of the inside of the container. So the surface area is actually the area that the water is in contact with. So here, if I call this A, the surface area here of A will actually be a half pi r squared, where r is 2. Sorry, where r is 9. So it'll be a half by 22 over 7 by 9 by 9. So that will work out to be something. 127.29, I could say, right? So that is just for A. Now let me move on to the other part. If I were to look at this shape here, which is the cylinder part of it, right? If I were to open this out, well, firstly I could call it B, and if I open it out, I will see that it is actually a rectangle, right? Now, what will happen here is that this distance here is actually the circumference, and this distance here is the 18. But we are actually dealing with half of this. So, I would need to find the area of, well, the circumference. Well, firstly, I'll have to find half of whatever I'm finding, because the water is half full. If it was quarter, like down here, I will find a quarter of this, right? So, since it's half full, I have to put this half here. And the fractions, the calculations that I'm going to put now would be the circumference multiplied by 18. Now, the circumference would be of this circle here. This circle has a radius of 9. So, the circumference formula is 2 pi r. So, it will be 2 by 22 over 7 by r, which is 9. So, that's the circumference here. And then I will multiply by 18. Now, this works out 509.143, etc. Right? So, I'll use this as my answer for part B. Now, lastly, I need to find the area of the surface area of this part here. That is actually, I'll call it C. So the area of that is actually, well, firstly it's a hemisphere, and then it's half of that, so it's actually a quarter. So I will actually put a quarter here to represent this fraction here, and then I'll find the area of a sphere. The area of a sphere is 4 pi r squared, which will work out to be a quarter by 4 by 22 over 7 by 9 by 9. And that works out to be 81 by pi, which is actually 254.47, something like that. Now, what is the total surface area of this whole, for this question here, where the water is in contact? Well, that will be the sum of this value, and this value. And that will actually be 190.902 centimeters squared when I add up all three values. So if you got that, you're perfectly correct. So congratulate yourself. Now let's move on to part B. Now we're moving on to part B, where we have to show that the volume is actually 972 pi centimeters cubed. Now the volume of the water is actually all of this here, right? Now it's actually half of the entire container. But this container is made up of smaller containers. It's made up of a cylinder here and a hemisphere here. But in this hemisphere, it's really half of the hemisphere that is filled. So if I were to look at the sphere alone, that is actually a quarter of an entire sphere. So the volume there will actually be a quarter of whatever volume it is for a sphere. Now the volume for a sphere is actually 4 on 3 pi r cubed. So if I put in this formula, I'll get the same thing here, but r cubed will actually be 9 cubed. So this actually will work out to be 243 pi. Now that is for just the sphere. Now let's work out for the volume now of this here, which is the cylinder. Now this cylinder is actually half full, even if I take off this section here, right? So if it's half full and the cylinder was upright like this, that means that volume is actually down here. That's actually how the container would be filled or so, right? So even though the whole height is 18, right, it might be a particular height or so, right? So what I can do actually is actually look at the cylinder alone, find the entire volume, which would be pi r squared by height, and then I could find half of it. So what will that be? A half by 22, sorry, I'll leave the pi by r squared, which is 9 squared, by height, which is 18. Now notice, I am acting as if the cylinder was upright like this, right? Because it doesn't matter how you place the cylinder. If it's lying down horizontally like this or vertically like this, half full means the same, right? So this is my half and this is the entire volume of the cylinder. This here is the entire volume and this is the half. So when I work out the multiplication of these two now, I am going to get 729 pi. So then that means that my total volume, guys, will actually be 729 pi plus 243 pi. And that works out to be 972 pi centimeters cubed. So that, everyone, proves that our volume is really 972 pi centimeters cubed. Now this takes me to the end of my video. I hope that you all have followed and understood everything I did. I started from the basics and then I got to this kind of messed up question. So please, feel free to watch it again, take notes, like and subscribe, and of course share with anyone else you feel may need the help. Thanks guys.